On number 9, we've got one of these percent solution problems. We're mixing pure water, which means it has 0% salt, with a 40% solution to get 200 ounces of a 5% solution, 5% salt. Well, I don't know how much pure water I'm going to be doing, so I'm going to call that my X amount. So the percentage of salt is 0%. It's going to seem kind of strange to write this, but the X amount is being multiplied by 0%. I'm adding in a 40% solution. So this is going to be 40%. Now you can convert that to a decimal, but actually it turns out on this problem you don't have to. So I'm just going to leave it as 40. Now I don't want to introduce a new variable like y. I also don't want to use x because that would assume that it's the same as the water. I know that in the end I'm getting 200 ounces. That means if I'm pouring in, I imagine a solution here. If I'm pouring in X amount of water, then there's something here to where this whole thing is 200. That means that this 40% solution needs to be 200 minus X amount. So the 40% solution has 200 ounces minus however much pure water I put in there. And the percentage for the overall solution is 5% times 200 ounces. So I have percentage times amount plus percentage times amount equals total percentage times total amount. And now it's not too terrible of an equation to solve, especially since I have 0 times x on the first part. So that's gone. If I distribute my 40 through this, I've got 8,000 minus 40x equals 1,000. So negative 40x, if I subtract over 8,000, is negative 7,000. If I divide by negative 40, I get x to be 175. So remember, the x amount was the water. So I have 175 ounces of water. If all together I'm going to have 200 ounces, that means I must have 25 ounces of the 40% solution. For number 10, we're looking at simple interest. She has an inheritance of $50,000. Part of it goes at 2% interest. Now on this one, I do have to convert these percentages to decimals. So 2% interest times some amount of that 50,000. I don't know how much it is. And then the rest she puts in at a 4% amount. So 4%, very similar to the mixture problem. Again, sorry, this is number 10. Very similar to the mixture problem. If the total is 50,000 and we already have X amount, the other amount is going to be 50,000 minus X. Her return was $1,400. So basically, I'm calculating the amount of interest on the 2%, the amount of interest on the 4%. Those will add together to give me the $1,400. So granted, I have some kind of nasty decimals here. This is still solvable though. If I distribute the 0.04 through this, this is going to give me 2,000 minus 0.04x. If I combine my like terms, 0.02 minus 0.04 is going to give me negative 0.02x. Also, if I subtract over the 2,000, that's going to give me negative 600. If I divide by negative 0.02 on both sides, that will give me 30,000. That is the amount that was invested at the 2%. The question asked how much was invested at the 2%. So we're done. $30,000. On number 11, we've got two trucks taking off in opposite directions. We're going to be using the distance equals rate times time here. So let's say truck 1 has a certain distance that he goes. He has distance 1. And he goes at a rate for a certain amount of time. Distance equals rate times time. Truck 2 goes 7 miles an hour faster. So he must have gone a little further. His distance is equal to a rate times a time, but I've already established R as the rate of the first truck. So for the second truck, I can call it the rate plus 7 miles an hour faster for a certain amount of time. Now, it does say that after 4 hours, they're 588 miles apart. That means that the distance trucker 1 drives plus the distance trucker 2 drives is going to equal 588. Well, now I can substitute. I know that D1 is RT. And I also know the time, that time was 4. So this would be 4R, or R times 4. Distance 2, I can substitute in. And again, I know that time is 4. So this is going to be 4 times R plus 7 equals 588. From here, I can solve for R. I've got to distribute. This is going to give me 4R plus 4R plus 28 equals 588. So if I combine like terms, subtract over the 28, divide by 8, and I get a rate of 70 for R. Now, make sure to answer the question asked. Find the speed of each truck and the distance each traveled. So for truck 1, his rate is R. So we know he went 70 miles per hour. I know he went 70 miles per hour for 4 hours. So times 4, he went 280 miles. For trucker 2, his rate was the 70 plus 7 more, so he must have been going 77 miles per hour, or averaging that. Drove for 4 hours. So he went 308 miles. For the next 4 problems, we are looking at some quadratics here. For number 12, I would first subtract the 3x over. So it equals 0. And now I can factor out a GCF of 3x from both terms. That would leave me with 3x minus 1. So now I'm going to use the zero factor property. Basically, I asked myself, what would I plug in for x to make the entire left side equal 0? For the first x, that would just be the number 0. For the second x, that would be 1/3. And a reminder again, what I'm doing is I'm saying 3x minus 1 has to be 0, and I'm solving for x. Number 13 can factor. And now it depends on how you learned factoring. Maybe you did factor by grouping, maybe you guessed and checked, maybe you used X box factoring. Whatever method you used, you've been using it for quite a while now. This one factors into 5x minus 3, 3x minus 2. And now I use the zero factor property on each one of these. Again, it's setting the factor to 0, which would give me 3/5 for x in the first factor. If I send the second factor equal to 0, that would give me 2/3. On number 14, we're going to use the square root property. So it's already been factored as a perfect square. So I'm going to take the square root of both sides. Now remember, that gives me, that gives me a plus or minus over here. And the square root of 44, if you do a factor tree with that, like maybe do 2 and 22, 2 and 11, you can simplify it to 2 root 11. And now it's just a matter of getting x by itself. So if I subtract over the 7, I'm going to put it out in front. It doesn't have to be, but this is typically how we see it written. And then I'm going to divide the entire right side by 4. Now you can leave this together, or you could split it into 2 fractions. Splitting it into 2 doesn't really do too much, so that would be acceptable. On number 15, wants us to complete the square or quadratic formula. I would suggest, since the leading coefficient is not a 1, I would suggest quadratic formula. Remember, that is negative b, so that's going to be 12 plus or minus the square root of b squared. So negative 12 squared is 144 minus 4 times a times c. So 4 times 5 times 5. That's going to be 100. All over 2 times a, which is 10. So I end up with 12 plus or minus the square root of 44 all over 10. Resist the temptation to reduce because we're not there yet. The root 44, just like I had on the previous problem, can turn into 2 root 11 again. Now it would make sense to split this into 2 fractions. 12/10 plus or minus 2 root 11 over 10, because I can reduce both parts of this. So this would become, excuse me, not 5/6, sorry. Change that. That'll be 6/5 plus or minus root 11 over 5. Again, I'm reducing the 12 and the 10. I'm reducing the 2 and the 10. That'll do it for this video.